Okay guys, this is gonna be as you can see right here, dot product proof. It's pretty much why this is equal to this. So, I just finished my math class, and I think I totally bombed the final, but anyways, this was like one of the first concepts we learned, and we used it throughout the whole thing. And yeah, so I was wondering why this is true. I tried to prove it a couple months ago. It didn't work out. I was able to prove the cross product, which I'll show in another video, but it relied on the dot product. So yeah, there we go. And just gonna use this as notes. Start from scratch. Okay, so first we'll draw, the coordinate system.
Don't make it too big.
And then we'll draw vector A. Draw vector B. Okay, and then just label this angle there to there A, and A to B, B. Okay, now we'll draw the components of this. Okay, so it's going to be bx. Let's see, it's going to be by. It's going to be ay. Ax. Okay. So here, okay, so pretty much we're saying pretty much what this pretty much like this acting in this direction. So let's say if we're just looking at here, one second. I shouldn't have drawn that there, but whatever. Okay, this is by, and then we'll not label this right now. Okay, so pretty much what this is saying, or what we're trying to get, is cosine B. So it's pretty much this length, this magnitude right here. Multiply that by A. So, that's like work and stuff like that. So, we're doing pretty much the absolute value of A, times the absolute value of B times the cosine of B, because that's going to give you this right there. It's equal to, oh shoot, whatever, you guys heard what I was saying. And then what the proof is, it says it's equal to A dot B. So, if you have the component forms of, shoot, did that again, like AX, AX, AY, BX, BY, it's going to equal AX, BX, plus AY, BY, and, it's a scalar, so, whatever that equals, it's just going to be a number. Anyways, so that's what we're trying to prove. So, first, what we've got to look at, or what I was looking at this morning was look at this triangle right here. And look how, these, I forget what, it's like the theorem of interior something. I don't know. Pretty much these are equal right there. So since this is right angle, this is going to be pi minus a, which means this right here, let me just make this more definitive. It's going to be pi minus a. So when we're looking at this triangle, let me first off say, pretty much what we're trying to get is either one side of this or one side of this. If we get this side, then what we do is just, the square root of b squared minus this squared is equal to this. And then we just multiply this by the absolute value of a. So, pi minus a, so if we have another, right angle, so 2 pi minus a, and, triangles, so pretty much this is equal to a. It's pretty much, this triangle has the same, proportions. The sides of the triangle are proportional to this triangle right here. And that is, quite helpful. So, what we want to do is, we want to find this side first. So, let me see. Gosh, got a lot of lines here. Pretty much, let me think here. Okay, so what we could do is we could say like this. Okay, we could say this length right here over this length right here, which we're trying to get, is equal to the absolute value of a over the cosine, or actually over ax. Yeah, not the cosine. We're not trying to use. We're not trying to get any angles in here. The angles were pretty much just used to find something that allows this thing to be proportional, so then we could compare the sides. So yeah, to get this, let's call it G. Okay. And we'll call this thing D. Okay, so BY is equal to G plus D. So pretty much, if we want to get this, let's see here. This is pretty easy because this triangle right here has components of D and BX. So then, like that, if you were looking at the inverse tan, it'd be like the inverse tan of D over BX equals A. But then you could also say the inverse tan of AY over AX equals A also. So pretty much what we do here, here, 1 second. Okay. We're going to start our work up here. So what we're going to say is D, 1 second, D over BX equals AY over AX, which means d is equal to ay over ax bx. Okay, now that we have that, now that we have d, g is equal to by minus d. It's equal to by minus d. Okay, so further is equal to by minus ay bx over ax. Okay, so just sort of highlight these so it's a little easier to find. Okay, so now what we want to do is, okay, so let's try to find this side right here, which we'll call z. And pretty much we could do the same thing how we found d. It's pretty much, so this is the hypotenuse is the longer leg or whatever. So it's going to be, longer side, or yeah, it's going to be like g over z. But since these two triangles are proportional, it's going to be g over z is equal to the absolute value of a over ax. So let's do something here. G over z is equal to the absolute value of a over ax. Okay, and solving for z is equal to what is that? Absolute value of a times g over you know what? It's actually, dang it. Absolute value of ax, or no, dang it. Whatever, you guys get it. Ax g times g. Just put g in parentheses. That looks like ay. Darn it. The absolute value of a. Oh, whatever. So we got that. So yeah, and now that we got that, pretty much all we have to do to find this, from here to there, which is really, you go up to this formula, it's really the absolute value of b cosine b. It's pretty much say absolute value, or yeah, it's pretty much just a square root, since it's a right triangle. Let me just write it out. It's going to be the square root absolute value of b squared minus z squared, and then to get, and this pretty much is multiplied by absolute value of a is this, and yeah, that's what we're getting right here. So we want to pretty much plug everything in, do some algebra, and see if we get pretty much this form: ax bx plus ay by. So now to put in the numbers, variables, the work, whatever. Okay, well, let's just solve for b squared minus z squared and take that square root out. So b squared, pretty much it's bx squared plus by squared, you know, absolute value, or actually no, it's actually not. The absolute value of b is equal to the square root of bx squared plus by squared. So if you square that, it's just going to be bx squared plus by squared, in parentheses, minus z squared. So, yeah, we'll just x squared, g squared. And then, you know, sort of same thing here. Ax squared plus ay squared. Yeah, okay, now this simplifies and, or plug g in. G is that, so it's getting a little messy now. Minus ax squared, let's see, g squared. X squared. 1 second here. Hold up. Okay, yeah, that's what I'm doing wrong. X squared. Okay, so, you know, g is right here. So, by minus ay bx for ax squared. Oops. Gosh. Okay. Hopefully you guys can tell that's ax squared. God, it looks like a chain delta x. Whatever. Okay. Over x squared plus ay squared. Okay, so now, so pretty much this is right here, b over square root. So we want to find something that's going to be able to, like, to be something squared, some polynomial or whatever, or, you know what I'm saying? So, I mean, just looking at this, you multiply this by this, and you get that out, and because it is a square root, if we have everything over the square root of, you know, this function right here, that's actually the same thing as absolute value of a. So since this is that, absolute value of a will cancel out. So yeah, we'll get to that later, but first let's just do this. Yeah, I'll try it out. Ax squared plus bx squared. Oh, dang it. Ay squared. Bx squared plus by squared. Minus. This is going to take up a lot of room, so we'll just do this first. Equals. Ax squared plus ax squared times bx squared. Plus, it's actually not 2, sorry about that. Ax squared by squared plus ay squared bx squared plus ay squared by squared. So, then you subtract, you know, this. Let's where should we put this? Okay, we'll just do it here. Ax squared, and then what is this? It's by squared minus, it's gonna be 2 because, you know, that. Okay. Ay, by, bx over ax. And then plus ay squared, bx squared, ax squared. Okay. And then it's just further equal to x squared by squared minus 2. Okay, so x squared over ax, just ax, so ax times this right there. Ax, ay, bx, by, just make it, you know, alphabetical order or whatever. And then ax squared cancels x squared, so ay squared, bx squared. Okay, so you look at this right here. It's by right there. And you could already see this looks like a polynomial or something. Something that's going to factor out, but actually not exactly. Okay, well, let's not get too far ahead. Okay, but so this is actually a minus, so this whole thing minus this, so should I rewrite it? I'll rewrite it. Ax squared, bx squared, plus ax squared, by squared, plus ay squared, bx squared, plus ay squared, by squared, minus ax squared, by squared, plus 2ax, ay, bx, by, minus ay squared, bx squared. Okay, let's see, ay, okay, so this and that cancels out, this, and, oops, that cancels out. Okay, so pretty much you're left with x squared, bx squared, plus 2ax, ay, bx, by, plus ay squared, by squared. So, if you look at this right here, it's going to equal, I mean, since it's ax, bx, and then ay, by, you just automatically think ax, bx, plus ay, by, and you think ax, bx times ay, by, you know, that's ax, ay, bx, by times 2, because you do it over again, whatever, which is this right there. So this does simplify into that. So going back to the original problem, we're pretty much just finding, so this is actually all over, so okay, this is equal to like this right here, that multiplied by that, and then everything like that. So we'll and then it's also the square root and stuff, so let's put everything. So it's going to be the square root of ax, bx plus AY BY squared over x squared plus AY squared, because we don't want to forget that right there, which we took out, now to put in. Okay, so that converts to that, and then we also got to get the absolute value of A in here, so absolute value of A is pretty much just this. AX squared plus AY squared. Okay, so that's gonna cancel. Yeah, that's gonna cancel, and then this right here, the square, let me cancel. Okay, and then this right there, the square root of that squared is just equal to AX BX plus AY, BY. So, look up here, that's what we got. So yeah, that's pretty much the proof right there. Doing it over again, it's a little easier. It took me like 2 hours to find this, but anyways, from here, now that I proved this, we go ahead and go prove the cross product, which is gonna say, what is it gonna say? Okay, actually, the cross product is pretty much just z times the absolute value of A. Let me think here. Yeah, I think that's what it is. So, yeah, sine of so we could prove it right now. You know what, we might as well. Let me get another piece of paper. Okay, I got another piece of paper. So yeah, with that in shot, pretty much the cross product is saying absolute value of A. This is absolute value of B, sine of the angle between them, which in our diagram is B. It's equal to A cross B, which A cross B is the what's it called? The matrix or whatever. I don't even get what these are, but whatever. A and B's are the component forms of AX and AY, and then BX BY, which is equal to cross whatever. I don't even get this. Maybe that'll be your next proof, but AX BY minus AY BX. So yeah, that's what we're trying to get right here. So yeah, going back to this. So yeah, if we look at this, absolute value of B times the sine of B, so pretty much the sine of B is equal to this over this, so you can multiply absolute value of B, you're pretty much just getting Z right here. So if we look over to here, Z is equal to that. So yeah, well, one second. before we do that, so it's saying this times this right here, and that's actually looking like a rectangle or something. For it's like base times height. If you move this over here, then it's like a rectangle right there. And well, actually, what this is saying is, I mean, one of the uses for cross product is to get the area of a parallelogram. So if you're to just imagine boom right there, and then okay, these don't look equal, but just say they're equal. Pretty much, if you're to put this triangle, move it over here, then this right here, you'd subtract it from the original length, but then you're adding it over here, so pretty much it's the same, which is going to be the absolute value of A, times Z, which is the height. That's equal to the area of the parallelogram, because it's going to be the area of the rectangle that's you make when you put this over here, fit into place. Nice right angles all around. So let me think here. So yeah, you're just gonna Z times the absolute value of A. Yeah, that's pretty much all. Is equal to, that. So plug in the numbers in. We got okay, you guys can see Z's right here. AX G over the absolute value of A times A. So it's gonna cancel out. Okay, I haven't even done this, so I'm not sure if this even works out, but I mean, you'll just look at this and it should work out. So times G, and then G is equal to right up here. Oh yeah, well, I mean, you can see it right here. I mean, easy, so easy money. G is equal to BY minus AY, BX over AX. So you look at that right there, you multiply this out, AX BY minus, well, since this cancels out, AY BX. So AX BY minus AY BX. Boom. Once you get the diagram, stuff is easy money. Cross product. And dot product. So that's really it. It's geometric representation or geometric proof of this stuff, and it really relies on angle A, and knowing that these angles are equals, and then that's equals, and then these triangles are equal, then you get the proportions. They're going to be proportional. So once you get that, solid. But yeah, I think maybe next proof might be like, what exactly do these do? I know these, I mean, I've just been using them, just by memorization, but I still don't really get how this really represents anything, so, or how doing this cross, that cross, and subtracting whatever is really what it's actually doing in here. So, anyways, I don't know if that made sense, but that's it. I'm gonna go edit this video. Yeah.